It's time to do some coding. This video will cover the very basics of Solidity, which will help you to understand how the code is built, and it will also help you to read smart contracts with confidence. So, this is what we will build in this video. And I know it might seem scary, but I hope that at the end of this specific video, you'll be able to understand what is written here and also actually explain what this code does to someone else. So, what Solidity actually is? It's a high-level programming language that can be used for designing and writing smart contracts. It's built with a strong influence of languages like C++, JavaScript, and Python. What does it mean that it's high level? Basically, it's very user friendly in terms of code creation for the developers, and it doesn't go into the intricate details of how computers, how servers work, how they manage the data in the very details, how they retrieve it, how they put it back into the memory. So it's actually a great option for those who want to start learning how to code within Web3. So let's start with the basics and talk about the different value types. What we will be doing is that we will be playing with different data, with different information. And we have to understand how this information can be categorized in different groups. Starting with integers, which are numerical values that can be divided into signed integers and unsigned integers. The difference is that the signed integers can have negative values, so below 0, and also positive values. Unsigned integers start at 0 and they cannot have a negative value assigned. Then we have booleans, which take only two values, true and false, which allowed the code to make decisions. So it will allow the program to decide if we should go to the right or if we should go to the left. More details on that a bit later. We also have addresses. So this is the value which is specifying the address of participants of a transaction. So if Benny sends some ETH to Mandy, Benny will have his own address and also Mandy will have her own address as well. We will speak about addresses in the next module in the Web3 identity one. Then enumerables. These are the user-defined data types, which give you a collection on different values that a variable can take. So they are predefined by the developer and nothing else can be used for a specific variable. So let's say that we have 1, 3, and 5, and these are the only three values we can use. We cannot use 2, we cannot use 4, or 10. Actually, I mentioned variables, but haven't talked about the variables yet. So let's actually have a look at what a variable is. You can think about it as a storage for code, for an object in the code, for some information in the code. And they are built through using a word that acts as a label where we can store some information inside. It's kind of like a block within our blockchain, but the difference is that it doesn't hold lots of different elements. It holds a specific value. And also what is important is that when defining them, we should know what kind of the value do we want to store inside. So if you have a look at the little code snippet here, what we do is that we create a variable called number, which is our label that we can later on reuse in the code. And we are also saying that number should hold an unsigned integer inside. Same goes for allowed, another variable that will store a boolean inside, so either true or false. And as I mentioned, variables are important so that we can actually reuse them later on in the code. It makes the code cleaner and more efficient because instead of using a massive number or a list of elements, or like a really, really long string of characters, we can just have it stored within one word, which we can then use throughout our computer program, which we can use throughout our smart contract. Let's now speak about the conditionals. If you remember the booleans, so true or false, I told you that they allow the programs to make decisions. And this is where if statements come in. They define different outcomes and possibilities of code execution based on some predefined conditions. What does it mean? If I look outside the window, I can say that if the weather is nice and if the sun is shining, I will take my sunglasses with me on a walk. Else, if the weather is not so nice and it's actually raining, I will take my umbrella with. And this is exactly what the code is doing as well. In the code snippet, you can see an if statement, which is the logic written into the code that will allow the smart contract to make a decision. It starts with the if keyword at the beginning, which is followed by the predefined condition. In this case, we are using a variable that we just defined in the last slide. If you remember, allowed is storing a boolean, which means that it will be true or false. So now let's assume that allowed is true. What we are saying that if this is true, we should perform a specific action. So as allowed is true, we will go here into those curly braces and we will return a number, which is the other variable that we just defined above. Once we return it, so we kind of give it back and the condition has been met, the action has been executed, we continue with the code. So we don't go into the further part of the if statement, which is located below. What happens though if allowed is set to false? Let's start from the top and have a look. So if this is true, which is not the case because allowed is false, we skip the action that happened last time and we go to the next part of the conditional statement, which is else. So if allowed is not true, execute this line of code, which here is returning a hard-coded value, which is simply 0. So as you can see, we can also use different values without storing them in variables. And once this is done, again, we can continue with the rest of the code that is written in the smart contract. Then we have functions. Functions which are gathering code that can be later on reused, and it stores a specific logic in order to accomplish a specific task. And this logic can be built from the different elements, such as the variables or the conditional statements that we mentioned. Moreover, functions usually take an input, perform some calculations inside of them, and also return a value. In terms of code, what you can see here is that the function is defined first with the function keyword, which you always have to use. Then we have the function name, which in this case is called surge number. We can also define some characteristics of that function. So we can say if this function can be used by anyone, if it can be actually used by other contracts, whether it's only meant to give you back some information, whether it's meant to process some information and do some calculations. And the curly brackets here that you can see at the beginning and at the end contain the logic. So what is between them will specify the specific action that should take place. This is also the place where we can create the variables, change their values, use the if statements to make the decisions, and also then return a specific value. And you will see more examples of that when we actually will start writing the code in a second. Let's move on from the slides to Remix, which is a tool that will allow us to build a smart contract, compile it, deploy it, and also test if it actually works how we want it to work. Following the link from the slides, we land on Remix, the interface to write smart contracts, which allows us also to compile, deploy, and test our code. As you can see, we have a dashboard here, and on the left side, there is a file explorer, so we can see the different files that we can play with. And what we'll do, we will create a new contract. So I'll click on the contracts folder and right-click to create the new file. Let's call it Surge and add an extension .sol. The file extension basically is informing the computer that this is a Solidity file and we will use Solidity code to build something inside. So I hit enter and it opens a new tab with an empty file for me to write in. What we need to start with is to define a license. So basically something that defines permissions for user to later on reuse the code. And we are using one of the most popular licenses, MIT, which basically expresses the permission for the users to reuse the code I will be writing here. Okay, next step would be to define which Solidity version we are using. The thing is that the coding languages are constantly developed and programmers are adding new functionalities and new features. And whenever we write in Solidity, we have to inform the computer which version of the language I'm using, so how the computer then actually read and understand the code. In order to do that, I will write pragma Solidity, and the version we are using would be 0.8, which is the stable version I can rely on. What we can also do here is to add a comment, which will be human readable text explaining what this line of code is doing. And I can do that through adding 2 forward slashes. And here, let's say that it defines the Solidity version. Okay, so now what we want to do is to write a contract. And everything I will be including in that contract will be contained within an object. An object meaning we will have curly braces that will be surrounding the code. And as you can see, when I typed contract, it changed the color right away. So removing T, it's white. When I add the T at the end, it turns blue. It means that the computer recognizes this keyword and it knows what it will do. It knows it will be a smart contract with some rules of behavior defined inside. Let's call it Surge. And I'll add my curly braces, in which now I can define the code inside. I called it Surge because we will be playing with some numbers, and surge means a sudden upward movement, a sudden increase. And what we'll be doing is that we will be increasing numbers, increasing integers, if you remember the values that I mentioned before. So what we can write here is basically say code our set of rules. So as we will be playing with numbers, it would be good to start with the number itself and create a variable that I can later on change. I can update the value that is assigned to it. And we will be using the unsigned integer, so uint, and let's call it number. As for the uints, if you remember, we said that these numbers have to be equal or bigger than 0, so no negative values. For clarity, I added a comment here that will remind you about what an unsigned integer is. Okay, but currently this variable is an empty box. It doesn't have any value assigned. So in order to assign some value that will be present in that variable in our smart contract from the beginning, we will use a special function that is called a constructor. So I will type it here, and as you can see, it's changed the color again, which means we are probably doing the right thing because the computer knows what a constructor is meant to do. What I need to add are brackets and then open the curly braces, which will define what this constructor, what this specific function is doing. And what we will do here is that we will define the initial value for our variables that we want to play with in the code. And here, what I can do is to take the variable that I have above and say that number will be equal to 1. And this statement here is assigning a value to a variable. So before we defined it, we created an empty box. And in line number 10, so as you can see, we are here, we take the value from the right side and put it into the box, the label that we have on the left side. So now whenever we start working with the search contract, the number at the beginning will always be equal to 1. Okay, so what I want my contract to do is to be able to give me the value of the number that we are playing with. This will be one function. The second function would be to ask the contract to increase the number that we're working with. So let's start first with the getter, the function that will give us a value. It will not change anything. It will just have a look at what is stored in the number, and it will give it back to us. So if you remember, when we are defining our own functions, we need to use the function keyword. After that, we can specify the name of the function, which in this case will be getNumber. Add the brackets. I will show you in a second what we can actually put in these brackets, but let's start simple. And we can then open the curly braces where we will define the logic of how we can actually give that number back. Before we do that, we can add some functionalities, kind of some definition to this function by saying that it will be a public function, which means it can be used internally within my smart contract. So this get number can be used by a different function, and it also can be used externally. So someone can actually take the contract that we're writing right now and reuse it in a contract that they are building. So this is a really nice feature that allows the reusability of the code across different contracts. The other thing that we can say is that it will be a view function. So as I said before, it is not changing the state of our variable. It will only read it. It will only allow us to view what is stored within the number. And lastly, we can also say what the function will actually do as an end result. And what it will do is that it will return a variable which holds in an integer, unsigned integer in this case, back. So whenever I want to use this function, I know that I will get a specific kind of a value as a return. So now, if we want this function to give us the number that we specified before, what we can say is that it will return a number. So it gives back the value which is stored within this box. So if we would be, if we want to use the getNumber function, what we will get back in this specific moment would be 1. So as I told you, the other thing that we want to do is to increase this number. So let's define another function. We will call it surge number because we want to grow this number, increase it a lot. Parentheses. This function is also public, so it will be reused externally and internally. And within the brackets, what we want to do is to perform an action changing the state of the code. What is important to note here is that the process of changing the state of the code, changing the state of information that we have on the blockchain, will require gas fees. And this is really important to keep in mind for the developers, as whatever code they write that will interact with the state of the blockchain will have a cost. So what they always want to do is to write code that will be as cheap as possible. So you want the gas fees to be as low as they can be. So what we will do here is that we want to multiply our number by 1,000. And also something I didn't mention, we always add a semicolon at the end of each line so the code can understand where every line ends. However, this is not enough because this is just a calculation. What we need to do is now store the result of this multiplication in our variable. So what I will do is I will type number equals number times 1,000. And what I'm doing here is that I'm overwriting the variable. So the number that I'm referring to here is the box that we defined in line 6. And in this moment, its value, it's 1. So you can just kind of copy paste 1 here to understand it better. And once we multiply it by 1,000, the number now will hold 1,000, the integer inside. So this is the basic functionality of our contract. And what we can do right now is to compile it. Compilation is a process of transforming the human readable code, where we have the constructors, numbers, functions, and so on, into a format that is readable by a computer function, so that it can actually know what we want to do in the computer language, and then to be able to execute it. So what we can do is to click on this icon on the left side with the arrows. And what we need to make sure of is that this file is saved. So you can always save it with Control S or Command S on your keyboard, which S stands for save. And if it's saved, you'll see that this little cross is here in the tab of the file. And we can click on Compile Surge Sol. Once we do it, you can see that it worked well because we have the tick icon. And the next thing to do would be to deploy the contract. Deploy, so upload it onto the blockchain. Currently, we will be working within something called a test environment. So we are not really affecting the real blockchain. We are just working in an experimental space. So it won't cost us anything. But you have to know that if you deploy a contract on the real blockchain, it will change the state of the blockchain, and it will also require the gas fees in order to perform that action. So as you can see, we are choosing an account from which we are uploading the contract. So that would be the account of the contract creator. We can set specific values, but I don't want to go here into the details. What we need to do is to make sure that we selected the right file. So we select the search contract from the contracts folder. And once I click deploy, what you can see here in the bottom tab is that creation of Surge is pending. This means that currently Remix is processing the code and is deploying it to its test network. And right now here, let me have a look. I think I need to mark the listen to all transactions to actually have the output of what happened in this tab, but maybe we can see that later. What is important is that on the left side, you can see that we have the deployed contracts. And if I'll click on the arrow here, you can see that the contract search is at this specific string, which is the location of the contract in the network, something I already showed you on Etherscan before. So what you can see here is that we have two buttons get number, and surge number. Thanks to those, we can actually test the behavior of our contract. So what I'll do, I will simply click on the get number, which will call a method. Call a method means that computer will execute this function, and what we should get back is our number, which currently should be equal to 1. So if I will say get number, you can see that what we got back is uint, which is the integer, and its value, it's 1. So it seems like it worked. Moreover, in here, you can see that we performed a call to the contract located at this specific address, saying that surge.getNumber, meaning that this function belongs to the surge contract, and more details. So basically, this is a transaction that happened. It was triggered by one account that we're currently using, and it was sent to the contract itself. The potential cost that we would have to cover in real life working with the real blockchain is 23,000 gas. And what we should be interested in here is the output. And as you can see, what we got is 1 that we could also see on the left side, which is the value of our number that we defined in line 10. Okay, so we have the getter function. Let's now try to change the state of the number and execute a transaction which will actually surge the number, increase the number. I will click on surge number button, and as you can see, we have another transaction that happened. And once we surged the number, please note that we are not returning anything. So if I will click on the transaction that happened, the output is empty. So how can I know that actually we managed to increase the number? We can reuse the getNumber function again, which will give us the most recent value of the number variable. So if I will click it again, what you can see that this value here changed, and it's equal to 1,000. So our contract works, but what I wanted to show you is how we can actually provide some input to a specific function. So that then we can use an if statement, a conditional statement in the code, to make a decision on which action should be actually taken. So what we will say is that we will provide another variable, which will be a boolean, and it will be called allowed, to our getNumber function. So it will be always expecting some kind of value that will be given externally. It means that we are not defining the allowed variable in the code here. We can pass it through the interface, which you will see in a second. And what we can do right now is to say that if allowed is true, we will execute this code. So we will return the number. Basically, we're saying that we can allow a user to read the value, or we don't allow the user to read the value. And in that case, if else is not true, what we will do is to return 0. So we're just always giving a hard-coded value without exposing what is hidden behind our variable. So as you can see, if we provide the variable here as an input, then the function can read it within its body. The body is what lies between the curly braces. And based on that, it can take a specific action. So if the user is allowed, we can provide the value of the number. If the user is not allowed, we will always return 0. So what do we need to do now? We need to make sure that the file is saved. So I'm clicking Control S in the background. You can't see my fingers, but you can trust me with that. We will go back again to the compilation panel here. And what I will do, I will click Compile S again. Compile S, compile surge contract. We have the tick icon, so everything went well. And now going to the last tab, what we have to do is to actually deploy the contract again. If you remember previous video, I said that the contracts are irreversible. So I already deployed my initial version of the contract without the input with the allowed variable. And I cannot simply update it. I cannot kind of deploy it again and replace that contract on the blockchain. What I need to do is, after compiling the newest version, I also need to deploy it. And this will be a whole new contract with a different address. So let's deploy it. And as you can see, it was successful. And the second contract is listed below here, the original contract that we deployed. So what is the difference now? What you can see are the two buttons that we had before, each being the individual function, the individual behavior. But now the get number has additional input field, which tells me that it should be a boolean and the name of the variable is allowed. So what we can do is to provide that value. So as booleans can be true or false, I will write here true. And when I will click on get number, what you can see is that I received back 1. If we change it to false, what will happen is that the conditional statement will have a look at allowed. So if this is true, it is not true, it's false. So we are skipping the line 15 and we are jumping into this part of code, which should return a hard-coded value. So if I will click on get number again and provide false as allowed, what you can see is that we got back 0. I think that at the beginning of this video, this contract might have looked a bit scary, but I hope that it's clearer right now and you can see how we can reuse different variables, how we can reuse the functions, how we can define them, how we can compile and deploy the contract.